Good morning, students. I would invite Arun sir to start the session.
Yeah. Thank you, ma'am. Excuse me, ma'am. Oh, excuse me, madam.
Yes, sir. Yes, sir.
Yeah, you can make me the host, ma'am, so that I can end the session at the end.
Okay, sir. Okay.
Yes, ma'am. Thank you, ma'am. All right. So, students, we're going to start with Newton's laws. We have transitioned into Newton's laws by doing constraint motion. So, we have done constraint equations. So, we know how a body moves when it's constrained to move with respect to some other body, right? So, now let's talk about laws of motion. We have been talking about the effect of motion, the effect of the cause, as in kinematics. But now we're going to talk about the cause of that motion. So a particle was accelerating, or particle was moving with constant velocity without zero acceleration. So those are the effects of a cause, and that cause is nothing but force. All right. So let's talk about laws of motion, which are called Newton's laws of motion, which are fundamental aspect of classical mechanics. All right, whole of mechanics stands on Newton's laws of motion. We are doing particle mechanics particularly, where we treat masses as point particles. When we treat them as bodies, uh, not as particles but as rigid bodies, then we talk about rigid body motion. But till then, we are going to talk about particle mechanics. So, rigid body mechanics is after particle mechanics. So, currently, we are going to deal with particle mechanics, where we treat bodies as point particles, right? Even if I draw a block, I would treat that block as a point particle. All right. Okay, let's talk about the laws of motion. We've got three laws of motion, students. Again, I tell you, we are studying the cause of the motion now. We have studied the effects of motion without studying the cause of motion, right? Not effects of motion, effects of some cause without studying the cause of motion. Now we are going to study the cause of motion, which was producing an effect, as in kinematics, right? So there are three laws of motion. The first law says the particle continues to be in state of rest or uniform motion unless acted upon by a force. That means the particle is at rest. Let's say there's a book on the table that will always remain over there. The book or the particle cannot by itself change its state of rest. All right, that's first law of motion. And also talks about uniform motion. This is state of rest, but a particle cannot change its motion if it's traveling with velocity v naught without any external force. This will continue to move with velocity v naught in a state of uniform motion. What is uniform motion? Constant velocity. So, particle, if it's moving with velocity v naught, it will continue to move with v naught forever. If particle is at rest, it will continue to be at rest forever if there is no external force acting on it. So only force can change its state of rest or uniform motion. All right, that's the first law. So a particle cannot by itself change its state of rest, or a particle cannot change itself by itself its state of motion. That means its velocity cannot change either in magnitude or direction by itself. There has to be a cause to change to produce that effect. Here also there has to be some cause to produce an effect of change of position. Otherwise, it is going to be rest forever. It is going to be in uniform motion forever. All right. This is the first law of motion.
Yes, sir.
Yeah. All right. All right. Okay. So now we've got second law of motion. For second law of motion, we need to define what is known as momentum. Momentum, you have it. You have an idea about momentum from lower classes, which is
Yeah.
m into v,
Yes, sir.
right?
Yes.
And what do we mean by momentum? How do we intuitively understand momentum? We'll talk about it later. But right now, consider it to be a formula which is nothing but mass times velocity. So momentum depends on both of velocity and mass. Let's say small particle is traveling with a velocity of 30 meters per second. It has got some momentum. But even if a vehicle is traveling with a 30 meters per second, it has got huge momentum. So it depends on mass and also it depends on velocity. If a huge body is traveling with two huge bodies are traveling with velocity v1 and v2, let's say a lorry. or a huge vehicle is traveling with velocity v 10 meters per second, its momentum is something. Same body when it's traveling at 30 meters per second, its momentum is more, something else. All right. So it depends on both mass and velocity. But intuitively, how do you understand momentum? We'll talk about it in a while, little later. Now, once we define momentum, the rate of change of momentum is proportional to the external force acting. That means force is the cause of motion, and force is rate of change of momentum. That is dp by dt. And this force and this change in momentum occurs in the direction of the external force. See, dp is what? If I have got average force, is delta p by delta t. This change in momentum occurs in the direction of the force. All right. So rate of change of momentum is force, and we know that momentum is mass times velocity. I can write this as F is equal to d by dt of mass times velocity. I can use product rule and differentiate this. I'll have v into dm by dt plus m into dv by dt. If mass is constant, if mass is not changing during motion, so dm by dt is 0, right? If mass is constant, derivative is 0. There's no change in mass with respect to time. So I'll have m into dv by dt, which is nothing but acceleration. So F is equal to mass into acceleration is, this is given by Newton's second law. All right, this is
Four.
Newton's law. But when the mass is constant, I'll get F is equal to mass into acceleration. So acceleration is proportional to mass, proportional to force, and inversely proportional to mass. Right? A is equal to F by m. So it is proportional to force and inversely proportional to mass. All right. Now, this.
Sir, can you repeat one second?
Yeah. See, I've got F is equal to dp by dt. I substitute P is equal to m into V. Now I use product rule for differentiation. What is it? V into dm by dt plus m into dv by dt. Right? Product rule F into G. How do I do? Fg dash plus F dash G. So Vm dash plus Mv dash. So V into dm by dt plus m into dv by dt. For masses, if the mass is constant, dm by dt is 0. So this becomes 0. What remains is m into dv by dt, where dv by dt is nothing but acceleration. So for constant mass, I can write this force equation. F is equal to mass into acceleration, provided the mass is constant. If the mass is not constant, the concept is different. Yeah, Bhavna. See, that's the law given. See, this equation mathematizes some experimental facts. So experimentally, it's observed that change in momentum is proportional to the force acting on it. All right. So that is how it is deduced from experiments and mathematized into this equation. And this is given by Sir Isaac Newton. So this is Newton's second law, and this was given by, this is called Kirchhoff's formulation of second law. All right. F is equal to ma was not given by Sir Isaac Newton. All right. This is deduced from here, and this was given by Kirchhoff's formulation of Newton's second law. And how do we know F is equal to dp by dt? Why is it that there's a law of nature, and how do we know that? Through experiments. Now, experiments, when you mathematize them, I get an equation, and that equation is F is equal to dp by dt. In experiment, you have seen that change in momentum delta p is proportional to the average force acting on it for a particular time dt, delta t. All right.
Yes, sir.
Okay. And the third law. Now we have got third law, which says, here is the first law. It continues to be in state of rest or uniform motion. And the third law says, every action has got equal and opposite reaction. So force exists in pairs. So whenever you think of, let's say a body is pushing another body, let's say I'm pushing this wall is pushing my hand in turn. In return, it's pushing my hand and I'm pushing the ball. So if a body is being pushed by other body, let's say F, then this body will push this body with, with the same force F, but opposite in direction. And the line of action of these two forces will be same. So these two action reaction pair always come in pairs. So every force come in every real force. There's a false force also, but we are talking about real forces now. We'll talk of false force tomorrow. But every real force comes in pairs, which is action and reaction. All right. Action acts on one body. Reaction acts on the body which is causing this action, which is responsible for this action. So if I'm pushing the wall will in return push me. So if one is action, the other is reaction. If that is action, if I consider that as action, this is the reaction. All right. So they always come in action reaction pair. And these two forces, action and reaction, always act along the same line of action. It can never happen that if I push a body over here, this is me. If I'm pushing this body like this body will push me along the same line of force in opposite direction. Along the same line. It doesn't happen that if I'm pushing over here, this will push me over here. No. All right. So line of action of the action reaction pair is same. All right. That has got important consequences mathematically. All right. So remember this one. You may not understand this right now. When you apply this thing in situations, you will understand. But right now you have to remember that line of action of the action reaction pair is same. If this force acts along this line, which is action, its reaction will act along the same line but opposite in direction and of the same magnitude. If I call this as action, this is reaction. If I call this as action, this is reaction. You can call any of the forces action or and the other force become reaction. All right. So there is no definition of that this is called action and this is called reaction. No, I can call either of these forces as reaction and the other force automatically becomes the reaction. And it's a very good habit to always think of the reaction. Whenever you talk of action, think of reaction force. So all the real forces have got action and reaction pair. False force doesn't have action reaction pair. What is false force? Tomorrow. All right. False force is also called pseudo force. Pseudo means false. But every real force has got an action and reaction pair. So whenever you think of an action, think of its reaction. If you see a force anywhere, think of a reaction. Where is reaction acting on? And they'll always act on these two different bodies. Action acts on this one, so reaction will act on this one. Or if action acts on this one, reaction will act on this one. Action and reaction don't act on the same body. That doesn't make sense. All right. If the action is on this body, its reaction is on the body which is responsible for the action. All right.
Yes, sir.
Okay. So that's third law. Now let's understand there is something called impulse. So students, have you read those two pages? The 2 pages which I asked you to read, could you read it? The ones who have the book, from the book, have you read it?
Yes, sir. Yes, sir.
Okay. Okay. All right. Good, good, good.
Yeah.
Okay, good. Okay. Now look at this. If I have got dp by dt, which is Newton's second law, is equal to F, this is Newton's second law. If I take dt on the other side, I'll have dp is equal to F dt, right? When I integrate on both sides, from t1 to t2, let's say at t1, my momentum is p1. At t2, my momentum is p2. What is integral dp p? P1 to p2 will be delta p is equal to integral f dt t1 to t2. Now, what is the definite integral we have seen? Definite integral is nothing but area under the ft graph. So change in momentum can be found out from area under the ft graph. So if given ft graph, we can find out change in momentum. All right. Given a pt graph, I can find the slope and I can find force. But if given a ft graph, I can find area and I can find change in momentum. Now let's say if I say particle starts from rest, so initial momentum is 0, and I ask you what is the final momentum. So that would be pf minus 0 is equal to area under the graph. So pf is equal to area under the graph. All right, whenever you see a definite integral, think of area. All right, in physics, the moment you see a definite integral, think of the area. Area between what and what? Area between this function and time axis.
Sir, can you repeat it once again?
Yeah, sure, I'll do it. Look at this. dp by dt is equal to f, which is Newton's second law. I write dp is equal to f dt. I integrate on both sides. So at t1, let the momentum be p1. At t2, let the momentum be p2. So integral dp is p2 minus p1, right? Which is delta p, right? Final minus initial is delta p, is equal to integral f dt from t1 to t2. What does the definite integral mean? Area under the graph. That's what you have seen in basic mathematics.
Yes, sir.
Okay, we integrate. See, so as to get p or delta p, I want to get as a function of t. See, if you remember, I've got dv by dt. Now look at this. dv by dt is equal to a. So dv is equal to a dt. Why do I integrate this? To get velocity as a function of time, right?
Yes, sir.
So here I want to get momentum as a function of time. So I'll get p2 minus u1, so delta p as a function of time. Or because the limits are given t1 to t2, which is a definite integral, which is nothing but the area under the graph. So delta p I get it as area under the graph.
Yes, sir.
Right. Okay.
Okay,
Now,
sir.
yeah. Okay, good. Okay. Now, given area, given a force as a function of time, I can get the momentum. That means I can get final moment. If initial momentum is given, I can get final momentum. How? Initial momentum, final momentum minus initial momentum is area under the graph. But understand one thing. We have actually done these problems on this one without, we have done problems on this one indirectly. I'll show you what I mean. Look at this. I've got delta p, right, is equal to integral f dt from t1 to t2. Delta p I can write as m delta v because mass is remaining constant. All right. If mass is remaining constant, m delta v is equal to integral f dt from t1 to t2. So delta v is equal to integral f by m. What is f by m? Acceleration.
A, sir.
Yeah,
Acceleration.
acceleration a dt from t1 to t2. Have we not seen this equation before? dv by dt is equal to a. In kinematics, you have seen this equation, right?
Yes, sir.
So we are doing the same thing, but with from the perspective of cause of motion. Here we just study the effect of the cause, but here now studying the cause of motion. So here we got change in velocity, but now I'm getting change in momentum. So these graphs we have already done it, but with respect to from the perspective of the effect. But now we are also studying this from the perspective of the cause of motion. All right. So this graph is not nothing new in this one, but I'll get momentum change in here. We got change in velocity. If I multiply mass on both the sides, I'll get change in momentum is equal to force into area under the FT graph. But here change in velocity is area under the AT graph. All right. So let's look at one problem. Problem says a force is acting like this. Its variation is like this. F versus T is like this. And let's say this is 10 Newton. And this is 1 second, 2 seconds, 3 seconds. All right. And initial velocity of the particle is 2 meters per second. At t equal to 0, my v naught is equal to 2 meters per second. And mass of the particle, let's say, is 1 kg. I have to find out the final velocity at t is equal to 3 seconds. At t equal to 3, I have to find out what is the velocity. What do I do? I've got an FT graph. The moment you see an FT graph, think of it, change in momentum. So this area under the graph will give me change in momentum. So if I say P2 at time t 3 seconds minus initial momentum P1 is equal to area under the FT graph. P1 is given as mass into velocity, which is 2. P2 is required. Is equal to what is the area under the graph? Can you tell me what is the area under the trapezium? Half
Sir,
times.
20.
Sorry, how much?
20, sir, 20.
Yes, absolutely right. So 20, P2 is equal to 22. So V2 is equal to 22 by M1, which is 22 meters per second. All right. Now let's see. Velocity has increased. Let's see, does it make sense or not? Look at this. What is happening? Force is positive, so acceleration is positive. Velocity is also positive, so it's accelerating. So again, after some time t, force has increased, acceleration has increased. It's still positive. So it'll go on speeding up, speeding up, speeding up, speeding up, speeding up. Here the force is reduced, but it's still positive. So acceleration is reduced, but still positive. So it is in the direction of velocity. It goes on speeding up. So that's why its velocity over at t equal to 3 is greater than v naught. V naught is only 2, but v naught, v that is huge. All right. Now let's do one more. And this change in momentum, integral f dt, is called impulse. All right. The intuitive understanding of impulse and momentum, we'll do it after some time. All right. If possible today, if not today, tomorrow. But mathematical definition of impulse is integral f dt, which is also change in momentum. So if I ask you impulse, the change in momentum or area under the ft graph, all right, gives me impulse. All right. Now I'll give you another force equation. Let's find out the final momentum of the body. So this is my ft graph. I have to find out time at which the particle initial velocity of the particle is 0. All right, particle starts from origin. I mean, at t equal to 0, initial velocity is 0. So what is the initial momentum? 0. So I have got delta p is equal to area under the graph. Now I want what time will the final velocity final momentum is also 0. P2 is 0. At what time is the final momentum 0?
Sir, 2, sir.
See at what is happening? At 2 what is happening? Force is 0. But area under this graph is non-zero. For momentum to be 0, delta pp to be 0, my area under the graph should be 0. So this area is positive. So I should cover some area over here below t-axis, so that this area
Sir,
should cancel out
4,
this area.
sir, 4. 4, sir.
4.
4.
Yeah, 4. Right. That's right. So 4. At 4 seconds, my momentum is same as initial momentum. So delta p is 0 at 4. But he said initial momentum is 0. So final momentum is 0 again at 4.
Yes, sir.
All right. Now let us understand this intuitively. Particle is at rest over here, but there is a force acting. So it speeds up. As time goes on, force is reduced, but still positive. So it speeds up further. Right? So at t equal to 2, it will be at the maximum speed. Okay. Now at t equal to just greater than 2, force is negative, but velocity is positive. So particle is slowing down. So it slows down, and stops over here. If I ask you what is the maximum velocity of the particle, at what time is the velocity maximum?
At 2.
At 2 seconds, right? Because till then it has been accelerating. After that, it's retarding. Right? Now, and what is
Yes,
the
sir.
maximum? And what is the maximum velocity? If I ask you, how do you do? I want P2 minus P1 is equal to area under only till here. So what is the area of this triangle? Half base height 10, right?
10, sir.
10. So P2 is equal to 10. So M into V2 is equal to 10. So V2 is equal to mass is given as 1. So V2 is 10 meters per second. So maximum velocity of the particle is 10 meters per second. And we'll again stop it for 4 seconds. All right.
Yes, sir.
Okay. Let's say I give you some function which is sinusoidal. If I give you a sinusoidal function like this of the force F, and this is sine. Yeah, tell me, is it sine or cos?
Sine, sir.
Sine,
Sine.
sir.
Sine, right. So I'll give you some function sine. Yeah, sine pi x. So F is equal to F naught sine pi x. So this is F naught and this is sine pi x. Pi t, sorry. Pi t, it's as a function of time. So what is this value? I'll write it neatly. Sorry. So what is this value, students? Where is there is a cut the t-axis first? What is the root of this equation?
So is it sine
Sir?
pi t?
Yeah, sine pi t. Yes.
Sir, is it sine pi by 2t?
No, it's sine pi t.
How, sir?
No, that's what. If it is sine pi t, I'm asking you what is the value of this time t when it becomes 0. I can give you sine pi by 2t also, but I've given you sine pi t. So when does it become 0? I put t
Sir,
equal to
can
1.
you repeat the question?
Sorry?
Sir, can you repeat the
Okay.
question?
Yeah. See, function is given as f naught sine pi t. All right. So at what value of time? So what is this coordinate at which time coordinate at which the function becoming 0? F is becoming 0.
Sir, pi, sir.
See, that is for sine t, but I give you sine pi t. See, sine kx, it gets compressed, no? The function gets compressed along x-axis. That's what you've done. So substitute t is equal to 1 there. It is 1. 1 second. Is it okay, students? Hmm? Students, is it okay?
No, sir.
Sir,
Okay.
can you explain again?
Yeah, sure, Ashrita. See, what I mean to say is sine kx raste, this graph is compressed by k times, right? Y is equal to sine kx raste. I'll have this will be how much? Pi by k, right? And this will be 2 pi by k, and so on. Now, if k is pi, this becomes pi by pi. This is 1 second, and that is 2 pi by pi. That's 2 seconds. మీరు t ఈక్వల్ టు 1 సబ్స్టిట్యూట్ చేయండి ఇక్కడ ఏమవుతుంది sin pi అవుతుంది sin pi is 0 t ఈక్వల్ టు 2 సబ్స్టిట్యూట్ చేయండి sin 2 pi what is sin 2 pi sin 2 pi is also 0
Yes,
is it
sir.
okay okay now
Yes.
again I ask you the same question at t equal to 0, my momentum is initial velocity of the particle is 2 meters per second. All right. Now, at what time will the momentum again become same? Momentum మళ్ళీ same momentum ఎప్పుడు వస్తుంది? Initial momentum is p naught. At what time will the momentum again be p naught?
టూ లోబ్స్ వచ్చాక మళ్ళీ సేమ్ అవుతుంది సార్
ఎప్పుడు
ఐ మీన్ టూ రొటేషన్స్ అయ్యాక
అంటే tell me what's the time?
S2.
Yeah, 2 seconds, because this area should be equal to this area. Area under the graph should be 0.
Yes, sir.
For change in momentum to be 0, see, I'm saying that initial momentum p naught ఉంది, మళ్ళీ p naught ఎప్పుడు అవుతుంది? So change in momentum is p naught minus p naught 0. If the change in momentum is 0, area under the graph should be 0. So area under the graph is non-zero till here, non-zero, non-zero, non-zero. It is 0 till 2. So at t is equal to 2 seconds, my change in momentum is 0. So it's again final momentum is over there is p naught. All right. Now if I ask you, at what time is the velocity maximum? Is the momentum maximum?
1.
At 1.
1. Excellent. And how much is that velocity? అడిగితే ఎలా చేస్తారు? P2 minus
Minus
p
P1.
naught is equal to area only on this part, area under this section.
1.
Now how do you find the area under this one? Integral f naught sine pi t dt from 0 to 1. F naught is a constant, it comes out. What is integral sine? Minus cos.
Yes, sir.
All right. And sine pi, so minus cos pi t into f naught by pi under limits 0 to 1. ఇది నెగటివ్ సైన్ తీసేసి 1 to 0 చేస్తాను. 1 to 0. All right. Now this is my delta p. P2 minus p naught is this much. So that is equal to f naught by pi cos 0 ఎంత 1, cos pi ఎంత minus 1. So I'll have 2f naught by pi is my p2 minus p naught. So p2 will be equal to p naught plus 2f naught by pi.
సార్
Yes.
మీరు కాస్ 0 ఎందుకు తీసుకున్నారు
చూడు ఇక్కడ 0 to 1 ఇంటిగ్రేట్ చేస్తున్నాను కదా, 0 to 1 లిమిట్స్ ఉంటాయి కదా,
సార్
ఇక్కడ నెగటివ్ సైన్ ఉంది కదా.
సార్
సో ఈ నెగటివ్ సైన్ తీసేసి ఐ హావ్ ఇన్వర్టెడ్ ద లిమిట్స్. ఆల్రైట్.
ఎస్ సార్
Now I'll substitute 0 first, then 1 next. So 0 substitute చేస్తే cos pi into 0, which is cos 0, is 1. Only 1 substitute చేస్తే cos pi minus of cos pi, which is minus of minus 1, is 2. 2f naught by pi. So I'm getting maximum as this one. All right.
ఎస్ సార్
Okay.
Yes,
Now
sir.
yeah. Okay. I'll ask you another question now. Then we'll go on to the next concept, equilibrium. And students, 2 examples book నుంచి మీరు చేయాలి. ఆ example నేను చేయలేదు. I'll do it, but not right now. If you understand that example, it becomes very easy for me to do it. I'll explain everything, but I want you also to do it simultaneously so that we can go faster. Okay, now my function is not this, but What is 5 minus 5 by 6? 5 by 6. Right? This is 5 by 6. This is 0. This is f naught. Can you tell me what is the equation of this curve? Sine నుంచి వచ్చింది. Sine function ని left కి shift చేశాను. When you lift a function towards left, it will be f of x plus a.
Yes, sir.
So నేను ఇనిషియల్ ఫంక్షన్ ఇచ్చేస్తాను. It is sin t. f of sin t ఇచ్చాను. f naught sin t. f naught sin t ని left కి షిఫ్ట్ చేస్తున్నాను. ఎంతతో షిఫ్ట్ చేస్తున్నాను is my question now. So that I get this equation. Students, think. If you don't get, you can ask me. But what I mean to say
So
is
1 by 6.
it is 5 pi by
So
6.
1 by 6.
It is 5 pi by 6. 5 pi by 6, not 5 by 6. 5 pi by 6. I got your thought process. You're almost there, Bhavna. Think again. It is 5 pi by 6.
Pi by 6, sir.
Ashrita,
Yes, sir.
very good. Okay. It's 5 by 6. How do you do that? Ashrita, how could you say that 5 by 6?
Pi minus 5 pi by 6.
Yes. See, ఇది ఇలా ఉంటే this was passing through pi. But now it's shifted towards left. ఈ shift now కావాలి. If it was starting from origin, it was passing through pi. It is now shifted towards left. ఎంత షిఫ్ట్ అయింది? pi minus 5 pi by 6. 5 by 6 తో షిఫ్ట్ అయింది. So this is minus 5 by 6. So my equation will be f naught sin t minus t plus 5 by 6 is my function f. All right.
Okay, sir.
Now I
Yes,
ask you a
sir.
question. Now the question is, if the initial momentum is p naught, after what time is my momentum again p naught? That means after what time is the change in momentum 0? After what time is the change in momentum 0? Time is in 5 pi by 6, pi seconds, 5 pi by 6 seconds. But it just doesn't make sense as of now. After what time is my momentum? Again, same as initial. That means after what time is my momentum 0? Change in momentum 0, sorry. Change in momentum 0. That means area under the graph should be? Sorry?
0.
0.
5 pi
Right.
by 3, sir. 5 pi by 3.
5 pi by 3 అవుతుందా?
Pi by 6, sir.
5 pi by 6 కి మాక్సిమం ఉంది చూడండి. ఇక్కడ ఈక్విలిబ్రియం ఉంది. It is being accelerating, speeding up. Its speed is maximum over here, then speed is reducing. I have to find out at what time is the momentum change momentum 0. That means this area should be equal to this area.
5 pi by 3, sir.
So I have to find out that time. So this area should be equal to this area. Yes, 5 pi by.
3. 3.
Is everyone okay with that? చూడండి, this area should be equal to this area అంటే this length should be equal to this length. This length ఎంత ఉంది? 5 pi by 6. ఈ length కూడా 5 pi by 6 ఉండాలి. 5 pi by 6 plus 5 pi by 6. 5 pi by 3.
సార్
Yes.
అది 10 π/6 లాగా రాసుకొని క్యాన్సిల్ చేస్తే 5 π/3 రాదా సార్?
అంతే 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 దట్స్ రైట్ 10 π/6 వస్తుంది. యూ క్యాన్సిల్ ఇట్ అవుట్ 5 π/3 వస్తుంది.
ఓకే సార్.
హూ ఇస్ దట్?
శ్రావణి సార్.
Oh, Shravani. Okay. Yeah, that's right, Shravani. Okay. Now, let's move forward. I'll give you as homework some pages, question number 6. But right now, let's go to concept of equilibrium. Impulse and momentum we'll understand. All right. As of now, all we know about impulses, impulse J is change in momentum, which is equal to f dt, integral f dt from t1 to t2. That's my change in momentum, impulse. And what is momentum? M into v. More about this later. But right now, we just know it as some equations, mathematical formulation. Okay. Now let's understand particle. See, I am talking about net force always. See, I'm saying the particle will continue to be in state of rest or state of uniform motion unless acted upon by net external force. That means if external force is 0, my particle will stay at rest. For instance, let's say I'm pulling this particle with 10 Newton here, and you are pulling this particle with 10 Newton over here. Will this particle move? Common sense Shaktadi, it will not move any. Right? It doesn't move. Right? 10 Newton is being pulled here, 10 Newton is being pulled here. So net force is 0, particle doesn't move. It will continue to stay in state of rest.
Yes,
All right.
sir.
But if I apply 20 Newton force, then net force is 20 minus 10. It will start moving towards right with under the action of 10
10
Newton
Newton.
force.
Yes,
Right.
sir.
So if the net external force is 0, it will continue to be in state of rest. Or if at all it were moving with certain velocity v naught, it will continue to move with v naught if it is 10 and 10. Provided the net force is 0, it continue to move with v naught. If the net force is 0, it will continue with v naught forever, or it will continue to be in state of rest forever. All right. So now let us
Yes.
find out. Now if I ask you, I am applying f naught, fs10, and you are applying fx. So what should be fx for it to continue in state of uniform motion? That means, in other words, what should be fx such that net force is 0?
10, sir. 10 Newton.
10 Newton. 10 Newton. Right. That's right. That's right. 10 Newton. I'm applying a force of 5 Newton. This is a 10 kg block. All right. It's on a horizontal floor. But look at this. I'm drawing horizontal floor and if I say this is G bar is into the plane. అంటే ఎలా ఉంది ఇప్పుడు నా సినారియో ఎలా ఉంది? ఒక బ్లాక్ ఉంది, ఆ బ్లాక్ ని పైనుంచి చూస్తున్నాను నేను. That's why my G bar is into the plane. Right?
Yeah, sir.
If I draw G bar like this, then what does it mean? That means I'm looking at the block from sideways. Ila. All right. Now, so if the moment I draw this G bar as like this, it means the horizontal plane I'm looking from above. If I draw it like this, I'm looking from vertical plane. Vertical plane lo నేను స్టడీ చేస్తున్నాను, ఇలా డ్రా చేస్తూ. ఇలా G bar ఇలా చేస్తే that means it's a horizontal plane I'm looking from above. Okay. Now I have to find out the acceleration of this particle. How do I find the acceleration? F is equal to mass times acceleration. Mass is constant, that's why I use this equation. So F ఎంత ఉంది? 5 Newton. Mass ఎంత ఉంది? I give you 10 kg.
10 kg.
Acceleration is a naught. So a naught is equal to 5 by 10.
1 by
Which is
1/2.
1 by 2. 1 by 2 meters per second square. All right. But now what I do, I apply another force of 3 Newton opposite to this one. Now I have to find out the acceleration.
1/5.
Yes, 1/5. So 1/5 is more or 1/2 is more?
1/2 is more.
1/5.
1/2 is more.
1/2 is more. 0.5 కదా? 1/5 is 0.2. 1/2 is 0.5. But common sense also tells me that acceleration next should be less because net force తగ్గిపోయింది. ఇది 5 Newton ఉంది, ఇది 3 Newton ఉంది. 5 minus 3 is 2 Newton. So this acted upon, this is same as if the block is acted upon by 2 Newton force towards right. Now this scenario is same as this scenario,
Yes, sir.
right? But there are two forces acting here. This one, I can replace these two forces with one force, which is called net external force.
Yes, sir.
All right. So these two forces, I'm replacing it with one effective force, which is producing the same acceleration as these two forces are producing. All right. Okay. Okay. Now, kinds of forces which we come across in this particle mechanics are gravitational force, one. Let's say I've got mass like this, m naught. Gravity is acting downwards. So forces on this block are, one is m naught g, which is gravitational force. All right. Okay. This is due to Earth. Now, I told you, whenever you see a force, a real force, think of it as reaction force. What is the cause of this force? Earth's gravitational pull. So its reaction will be on Earth. So I've got Earth like this. So Earth will be pulled with m naught g. Now look at the students. You put m naught g act on the kinda. This floor will push it up with some force, which is reaction force R naught.
Yes, sir.
Now reaction of this
Same
R naught will be
magnitude would ఉంటుంది.
correct because
Same
vertically it's not
magnitude.
moving. Same magnitude is equal to m naught g ఉంటుంది. We'll come to that. But this reaction equal ఉంటుంది R naught the on table.
Wow. Yes, sir.
All right. So whenever you think of force, think of reaction immediately. Because all real forces have action reaction pair. మనం pseudo force, false force మాట్లాడినప్పుడు ఈ thought is very important. That action reaction ఉంటుందా లేదా? ఆ false force కి action reaction ఉండదు. But real forces have. So ప్రతి real force కి మీరు it should be a practice, it should be a habit. Second thought వచ్చేయాలి immediate గా that where is this reaction అని. Alright, ఇక్కడ m naught g చేశాను, దాని reaction ఇక్కడ ఉంటుంది. R reaction is because of the floor pushing this one. So దాని reaction R లో ఉంటుంది. On table ఉంటుంది. If I push this with F naught,
Normal reaction, sir. Normal
yes,
reaction.
yes, that's called normal reaction. That's called normal reaction. That's absolutely right. That's called normal reaction because it is normal to the surface. It is perpendicular to the surface. For instance, I've got circular hemispherical table. ఒక బ్లాక్ ఇలా పెట్టాను. So I'll draw a tangent here. That tangent కి perpendicular నా normal reaction ఉంటుంది. Let's say if I have a block here. Okay, block ఇక్కడ ఉంది. My normal reaction will be I draw a tangent here and normal to that will be my reaction. All right. If I have an inclined plane like this, now I block on that. Normal ఇలా ఉంటుంది, perpendicular ఇలా ఉంటుంది. My normal reaction will be along that one. All right. Its reaction again on table, its reaction on table, its reaction on wedge. అదే ఇలా ఉంది అనుకోండి, నా ఆబ్జెక్ట్ ఇలా ఉంది, రాడ్ ఉంది, ఇది వాల్ ఉంది, ఎడ్జ్ ఉంది. How will the normal reaction be? It will be perpendicular to this one. So normal reaction on this will be like this. Normal reaction on the edge will be opposite to that, along the same line of action. Right? Action reaction pair always along the same line of action. Okay, that has got consequences in rigid body mechanics. Okay, that is very important because this fact I told you, remember the fact, but the consequences of the fact we'll understand later. The fact is, action reaction pair always act along the same line of action. ఈ line of action action ఉంటే along the same line of action reaction it ఉంటుంది which is of the same magnitude. So vector is just flipped here. Vector flip అయిపోతుంది అంతే. కానీ ఇదేమో ఈ బాడీ మీద యాక్ట్ అవుతుంది, ఈ బాడీ మీద యాక్ట్ అవుతుంది. Alright.
Yes, sir.
Yes,
Okay.
sir.
Okay, now let us draw some normal reactions. ఇప్పుడు నార్మల్ రియాక్షన్స్ ఎప్పుడు నంబర్ ఆఫ్ పాయింట్స్ ఆఫ్ కాంటాక్ట్ అన్ని నార్మల్ రియాక్షన్స్ ఉంటాయి. ఇక్కడ ఎన్ని పాయింట్స్ ఆఫ్ కాంటాక్ట్ ఉన్నాయి? ఇక్కడ ఒక కాంటాక్ట్ ఉంది, ఇక్కడ ఒక కాంటాక్ట్ ఉంది. ఓకే, దీస్ ఆర్ టూ వాల్స్. These are two walls. This is the floor. These are two cylinders or spheres. Spheres తీసుకుందాం. So here there is one point of contact, third point of contact, fourth point of contact. So I'll have four normal reactions. In the scenario, not on the same body. In the scenario, నాకు ఇన్ని normal reactions ఉన్నాయి. ఇక్కడ ఎలా ఉంటుంది normal reaction on the sphere? Towards left.
Left.
Its reaction is on the wall towards right. Along the same line of action. Right? Along the same line of action towards right. ఇంకా ఏదైనా నార్మల్ రియాక్షన్ ఉందా దీనికి? ఎస్ ఉంది. I'll draw a tangent here. I draw a tangent here. Perpendicular to that, I'll have a normal reaction. R1, R2 రాద్దాం. Or N1,
Yes,
N2.
sir.
Whatever you are comfortable with. Right? N1, N2 రాస్తే normal reaction గుర్తుంటుంది. So I'll write N1, N2. Right? Now, its reaction will be where? N2 reaction ఇక్కడ దేని మీద ఉంటుంది?
Northeast.
ఓకే రైట్. ఇది స్పియర్ 1, ఇది స్పియర్ 2 అనుకుంటే స్పియర్ 1 మీద నార్త్ ఈస్ట్ డైరెక్షన్ లో N2 ఉంది. దాని రియాక్షన్ ఎక్కడ ఉంటుంది? దేని మీద ఉంటుంది?
Tangent.
2 మీద, sir.
2 మీద
Two
ఉంటుంది.
particles.
రైట్. సో 2 ది నేను డ్రా చేసుకుంటే ఈ నార్మల్ రియాక్షన్ ఇలా ఉంది, N2 ఉంటుంది. బట్ ఐ మీన్ ఇన్ మ్యాగ్నిట్యూడ్ N2 ఉంటుంది, బట్ ఇన్ దిస్ డైరెక్షన్. ఇంకా ఈ నార్మల్ రియాక్షన్ ఇలా ఉంటుంది, కింద నుంచి నార్మల్ రియాక్షన్ ఇలా ఉంటుంది.
Yes,
Okay.
sir.
దీని రియాక్షన్ దేని మీద ఉంటుంది? ఆన్ దిస్ వాల్. దీని రియాక్షన్ నార్మల్ రియాక్షన్ దేని మీద ఉంటుంది? ఆన్ గ్రౌండ్ ఆన్ ద టేబుల్. బట్ దెర్ ఆర్ టూ మోర్ ఫోర్సెస్. mg, ఇది m0g అనుకుంటే, m1g అనుకుంటే, ఇది m2g అనుకుంటే, m1g దేని మీద ఉంటుంది రియాక్షన్? m1g రియాక్షన్ దేని మీద ఉంటుంది? ఆన్ ఎర్త్.
Sir.
ఎర్త్ మీద m1g ఉంటుంది. m2g రియాక్షన్ దేని మీద ఉంటుంది? ఆన్ ఎర్త్ m2g ఉంటుంది. Alright?
Yes.
But whenever you study a body, you only isolate that body and draw all the forces only on the body. Alright? When you do that, that's called FBD, free body diagram. You free the body from all the whole of the system, you free it and you draw all the forces on that body. You draw a diagram of the body, it's called free body diagram. You isolate the sphere, దీని మీద ఏమేమి ఫోర్సెస్ ఉన్నాయి? N1, N2, M1g. ఇక్కడ E3 normal reaction, ఇంకా M2g. So I have drawn all the forces. In FBD, you are supposed to draw all the forces, including false forces. But we are not about false force right now. But you are drawing all the real forces on a body. When you isolate the body and draw, that's called FBD. Free body diagram. Okay. Fine. That's fine. So got a free body diagram. What is free body diagram? I repeat, I isolate the body and I draw all the possible forces on the body. Only all the forces on the body. If their reactions, I'll talk about it. I'll think about reactions later. But when I draw that particular body, I'll draw only all the forces on that particular body. 100 forces unte 100 forces draw చేసుకుంటాను. 1 force unte 1 force draw చేసుకుంటాను. So I'll draw all the normal reaction ఉంటుంది, mg ఉంటుంది, friction unte friction ఉంటుంది, false force unte false force కూడా ఉంటుంది. Sorry?
Frictional force, sir.
Frictional force, but right now let's say frictional force లేదు. Friction 0 ఉంది అనుకుందాం. Smooth body ఉంది అనుకుందాం. That's very polished body. లేకపోతే we have put some fluid which is making it very smooth. or powder వేసాము, it has become very smooth. So friction లేదనుకుందాము. For this chapter there is no friction. All right, next chapter we have friction. Friction is very complicated concept. Problem solving లో friction is very difficult. But right now we don't have friction. So we will study idealized case now. So I said, actually reality లో friction ఉంటుంది. You cannot escape from friction. But idealized situation తీసుకొని we'll first study system without friction. Then we'll go to realistic case where you have friction. All right, always. అందుకే కైనెమాటిక్స్ లో కూడా ఏం చేసాం మనం, ముందు డ్రాగ్ ఫోర్స్ లేకుండా చదివాము, కాన్స్టెంట్ యాక్సలరేషన్ చదివాము, వేరియబుల్ యాక్సలరేషన్ చదివాము. దెన్ వీ కేమ్ టు డ్రాగ్ ఫోర్స్, రెయిన్ డ్రాప్ ప్రాబ్లం చేసాము. అది రియలిస్టిక్ ప్రాబ్లం. అలానే ఇక్కడ కూడా వితౌట్ ఫ్రిక్షన్ ముందు చదువుతాము. దెన్ విల్ గో ఫర్ రియలిస్టిక్ కేస్ విత్ ఫ్రిక్షన్. ఆల్ రైట్.
Okay, sir.
Now along with FBD there is something called MAD. MAD. It's called mass acceleration diagram, which is not of that significant in particle mechanics, but rigid body mechanics. So mass acceleration diagram is very important. What it says is you show all the acceleration of the particle. ఇప్పుడు ఫోర్సెస్ ఎలా చూపించాము, like that we will show all the acceleration of the particle. Rotational acceleration, translation acceleration, or combined system ది మనం acceleration చూపిస్తాము. So FBD ఇంకా MAD together go when we write equation for FBD and MAD. Relating FBD, see FBD is the cause of MAD. Forces over here are the cause of acceleration here. So when I write the equation F is equal to ma, my problem is solved. So whole of your mechanics is just this one. You choose a reference frame, ground చూసుకున్నాము, అక్కడ నుంచి ఫోర్సెస్ డ్రా చేస్తాను, అన్ని ఫోర్సెస్ డ్రా చేశాక MAD డ్రా చేస్తాను, చేశాక F is equal to ma రాస్తాను. Your any mechanics problem, any damn mechanics problem, no matter how tough it is, Olympiad, graduate level, postgraduate level, any level problem, boils down to these 3 steps. First step is choose a reference frame. Starting లో ground తీసుకుందాం. All right, we'll see what are the other reference frame later, but starting లో ground reference frame. I choose a reference frame, I draw the FBD in that reference frame, and I write the MAD in that reference frame. I relate FBD and MAD, F is equal to MA, that's it, my problem is solved. ఎంత కాంప్లికేటెడ్ ప్రాబ్లం ఉన్నా కూడా if I can just draw FBD correctly, we are done. If my FBD is correct, we are done. All right, no matter how complicated the problem is. Oh, time is up. Okay, I'll just continue for a minute, then we'll stop. I've got a block like this. Gravity is acting downward. So normal reaction దీని మీద due to floor ఇలా ఉంటుంది, mg ఇలా ఉంటుంది. Is normal and mg action reaction pair?
Yes, sir.
No, they're not action reaction pair. Cause is different. చూడండి, mg is because of earth. So mg ది రియాక్షన్ ఎర్త్ మీద ఉంటుంది. Normal is due to table. దాని రియాక్షన్ టేబుల్ మీద ఉంటుంది. So normal on block and normal on table are action reaction pair. See, it so happens that n is equal to mg in this case. N equal to mg ఉంటుంది. That's the magnitude of the length of the vector is same, but they're not action reaction pair.
Yes, sir.
Okay, there's a
Okay,
difference. There's a difference. See, ఇప్పుడు ఏమవుతుంది, వర్టికల్ మోషన్ చూస్తే I told you, I'll see reference frame, నా గ్రౌండ్ తీసుకుంటాను ఇనిషియల్లీ, స్టార్టింగ్ లో గ్రౌండ్ తీసుకుంటాము. రైట్, there are other frames also, but let's choose ground. Okay, now all the upward forces ఎన్ని ఉన్నాయి, n, downward forces ఎన్ని ఉన్నాయి, mg. n minus mg is the net force, is equal to mass into acceleration. What is the acceleration of the particle? 0. It's not moving. ఒక బుక్ ఇలా పెట్టాను, అలానే ఉంది. So what is the acceleration of the book with respect to ground? 0. So m into 0. So n is equal to mg వస్తుంది. So n is turning out to be equal to mg. That means vector length of n is equal to vector length of mg, but they are not action reaction pair. Normal reaction, the reaction pair ఇక్కడ ఉంది on table. mg the reaction pair on earth ఉంది. So these two are action reaction pair. These two are action reaction pair, but n and mg are not action reaction pair. All right, is it clear?
Yes, sir.
Yes,
Okay.
Clear.
Okay, students. So let's stop here. అండ్ కన్స్ట్రెయింట్ మోషన్స్ ఒకసారి రివైజ్ చేసుకోండి. ఏ కన్స్ట్రెయింట్ మోషన్ అంటే పులి కన్స్ట్రెయింట్స్ అన్ని రివైజ్ చేసి వెజ్ కన్స్ట్రెయింట్ కాకుండా పులి కన్స్ట్రెయింట్ రివైజ్ చేయండి. యూ కెన్ డు హెవీలీ డూ దాట్ ప్రాబ్లమ్స్ ఇన్ నెక్స్ట్ క్లాస్. రైట్, కన్స్ట్రెయింట్ మోషన్ రివైజ్ చేసుకోండి. అంటే ఇలాంటి if acceleration of this is a naught, can you tell me what is the acceleration of this one?
Sir, A by 2.
A by 2, sir.
A/2, sir.
A naught by 2.
Pakka?
Mm, yes, I think A naught by 2 only.
Okay,
Yes,
let us say
sir.
this. No, let's say this shifts by x. All right. Let's say this pulley shifts by x. Oh, this is not moving. There's a block here. Sorry. Pulley A naught unte adi kuda A naught untundi, but this is A naught. Actually, sorry, the diagram was not complete. Sorry. Ippudu cheppandi. This is A naught. What is the acceleration of this block?
Is it 2x?
No. Think. A naught or 2 naught or 2 A naught or
Sir,
A naught by 2.
by 2. Sir, A naught by 2.
Okay, A naught by 2. Vignesh?
2 A naught, sir, I think.
No. Either use push-pull method because the one end of this thing is fixed, or I'll say this is A naught, this is
Okay.
0. 0 plus A naught
Yeah,
by 2 is A naught by 2. Either use pulley method or use push-pull method. So A naught by 2 ఉంటుంది ఇది. Alright, revise this system. Pulley system ని revise చేసుకొని రండి. Alright, we're going to heavily solve some interesting problems on this one.
Okay.
Alright? Okay, let's stop here, students. Have a nice day, have a great day, but just take some 15 minutes of time and revise this and come back.
Okay, sir.
Alright, మనం equilibrium చేస్తాము first. After doing equilibrium, we'll go to such problems. Constraint motion already అయిపోయింది కాబట్టి constraint will bypass and will solve apply laws of motion to such systems. Alright, students, thank you all. Bye everyone.